Now we do part 4 of the question 1 of exercise 2.4. We use laws of exponent, but before this we have to deal with the composite number 81, 243 and 9. We find their prime factors by taking their LCM and we get 3 3s are 9, 3s are 27, 3s are 81, whole power n dot 3 raised to power 5 minus we apply law of sum of powers. Conversely, the powers which are in the difference form, they are separated with their bases. 3 common base, 3 raised to power 4n dot 3 raised to power minus 1. Along with 243, which is a composite number, we get its prime factors. 3 3s are 9, 3s are 27, 3s are 81, 3s are 243. Whole divided by 9, 3 multiply 3 whole power 2n 3 raised to power 3. In the next step, in a product, the bases are same and the powers are added. That is law of sum of powers. 3 raised to power 4 whole power n dot 3 raised to power 5 minus 3 raised to power 4n multiply. In place of dot, we can write multiply sign 3 raised to power minus 1. As we know that a raised to power minus n is equal to 1 over a raised to power n. According to that, we write as 1 over 3 raised to power 1 multiply 3 raised to power 5 whole divided by 3 raised to power 2 whole power 2n 3 raised to power 3. In the next step, we apply law of power for the first part of first term. 3 raised to power 4 and it becomes 4 multiplied to n dot 3 raised to power 5 minus 3 raised to power 4n multiply 1 over 3 multiply 3 raised to power 5. In denominator, we get 3 raised to power 4n. Why? Because 2 multiplied to the 2n according to law of power dot 3 raised to power 3. We apply law of power, so it becomes 3 raised to power 4n dot 3 raised to power 5 minus 3 raised to power 4n dot 3 raised to power 5 dot 1 over 3. We exchange the positions of these two values according to commutative law. So whole divided by 3 raised to power 4n dot 3 raised to power 3. 3 raised to power 4n dot 3 raised to power 5 as common. As we observe that these two values are common in both of these two terms, which are determined by plus and minus sign. So in these two terms, we take 3 raised to power 4 and 3 raised to power 5 as common. In first term, nothing is left, but it means, according to mathematics general basic principle, that is 1 is left over there minus. In the second term, 1 over 3 is left whole divided by 3 raised to power 4n dot 3 raised to power 3. Instead, we observe that common basis over here and we combine them by applying law of sum of power. 3 raised to power 4n plus 5, 4n taken to the numerator, 4n, 3 is taken to the numerator according to law of quotient of power with same base, into we take it LCM. 1 3s are 3, 3 1s are 3, 3 1s are 3, 1 1s are 1. In the next step, we have 4 and cancelled, like terms, different signs cancelled. 3 raised to power 5 minus 3, we get 3 raised to power 2, and in the next part we get 2 by 3. As we know that 3 raised to power 2 means 3 multiply 3 multiply 2 by 3, we open the bracket, 3 cancel by 3, 3 2s are 6, and that is the simplified form of part 4. In question number 2, we have to show that left hand side is equal to right hand side. For this purpose, we take left hand side first and apply the laws of exponent. X raised to power a over x raised to power b whole power a plus b, x raised to power b over x raised to power c whole power b plus c, x raised to power c over x raised to power a whole power c plus a. Applying law of quotient of power with same base on the internal part of the brackets, we get x raised to power a minus b raised to power a plus b, x raised to power b minus c whole power b plus c, x raised to power c minus a whole power c plus a. As we know that this formation is required to apply the law of power. So on each section we apply this law. X raised to power a minus b multiply a plus b. X raised to power b minus c multiply b plus c. X raised to power c minus a multiply c plus a. We apply formula or we multiply these two factors. So we get x raised to power a square minus b square into x raised to power b square minus c square into x raised to power c square minus a square. In a product, if bases are same, then the powers are added, and these three values are in product form. So we take x as a common base and add their powers, a square minus b square plus b square minus c square plus c square minus a square. Like terms having different signs, they are cancelled. A square plus cancel with minus a square, minus b square cancel with plus b square, minus c square cancel with plus c square. We get, as all the values cancel, we get 0 in power. We know that according to law of quotient of power with same base, x raised to power 0 is equal to 1. So therefore we put here 1, and hence we got the right hand, this value equal to right hand side.